Hi, in this video I'm going to demo my final game project for my degree and talk a little bit about some of the features and gameplay. First off, my game focused on the arcade game template. Phantom Path takes inspiration from the PS1 and PS2 era of gaming, combining fun mechanics such as jumping, double jumping, attacking, dashing, or a combination of different actions. But what makes this game important is its use of procedural and random generation, which is increasingly used in the gaming industry by big-budget game studios, or even small indie developers. Recently, Starfield, a Bethesda game, used procedural generation for their planets. I used something similar in nature to generate levels, some of which are endless. So, let's head on to the level select screen. As you can see, there are a few levels here. For now, we will focus on the Umbris Ruins, which uses a combination of fixed prefabs and random asset placement. As you may have noticed, the game rendered all of that in real time. This is the nature of my procedural and randomly generated content. In Phantom Path, many mechanics can be used to interact with the world, for example, jumping on crates or attacking them. But be careful, as some crates are not necessarily friendly. All is the same for enemies that we might find in the game. Phantom Path also makes use of some flow mechanics such as sliding, keeping the flow of gameplay different and engaging when moving from level to level. This game, while playable with a keyboard, is also playable with a controller, which I'm using right now for this demo. Let's talk about the menu. The menu runs in real time, and any changes, customizations, and features affect how the game looks and performs. I decided to use a real-time menu, so gameplay doesn't feel interrupted. Let's find a checkpoint and end the run. In Phantom Path there are various levels and other mechanical depths to them. While I can't show every possible encounter, these few levels show what is possible with procedural generation, such as mixing fixed assets and changing how they look and how they change the environment. How about we try the other levels? This level is completely infinite in any direction you move in. This is more of an endless explorable type of level, instead of the forward level generation. Examples of games that use this technique are No Man's Sky and Minecraft. Here's another level with the same generation algorithm. But how does all this work? The best way to show you is to see what happens in the background in the Unity editor.
Let's look at a side-by-side comparison. On the left we have the editor view and on the right, we have the gameplay. As you can see, the UI is two curved meshes that are being rendered by two cameras, one a display camera and the other the render camera where everything is brought together. Basically, we are doing a technique called passing, where two renders are used to achieve 3D UI and render and resolution effects such as the 8-bit feature we have. All for the purpose of not going through complex 3D placements in the actual gameplay and camera view area. Everything is separate and easy to modify and change without affecting any of the gameplay elements or level design. Now for level generation. An algorithm deals with the placement, management of assets and destruction or culling of these assets to maintain performance. As you can see, the levels manage themselves using the player's position. This is an example of forward generation that is used in games like Subway Surfer. You can see each section being triggered and culled accordingly. Next up is player movement. How do we get the player and enemies to move around without any nav meshes? I used character controllers and raycast logic to manage how the movement and other elements affected these characters. For now, let's focus on the actual playable character. By using a detection sphere I can detect the ground, and apply forces to the controller based on that information. Gravity, player input, and velocity, all of this come into play, and create realistic, smooth movement for the characters. All of that includes modified animations from Maximo, resulting in a satisfying and responsive game character with animations to match. All these animations are triggered at specific times and conditions. Finally, let's have a look at the effects that are used when switching all the post-processing off. We can see a much clearer, but not immersive render of the game. By using Cinemachine and some extensions, I was able to create a vibrant yet dark undertone to make this game appeal much greater. Take a look at how switching these effects off affects how the game looks and feels. Effects such as bloom and depth of field all use their own image techniques to achieve a certain effect. Bloom takes advantage of vibrant colors, HDR, and blurs them with surrounding pixels. Depth of field uses pixel depth as well as the camera combined with the technique of Gaussian or bokeh to smooth and blur objects that cannot be seen based on distance. Other effects like vignettes, color adjustments, etc., use pixel information. These can be color, edges, depth, and more to get a desired look. One more thing I want to add here is the infinite level generator and how that works. It uses collision-based overlay detection and the player's position to generate the levels and assets, making the level infinite in any direction. I used some mathematics to create block-based procedural positioning, where the assets are managed in a separate area and the levels are used to place them in the correct position and orientation. Games like Minecraft use this technique and are responsible for generating worlds that are complex and full of depth. While my implementation is basic for the purpose of scope and the template requirements, it keeps the game feeling different but similar whilst also keeping room for improvement in the future. Thanks for watching this in-depth demo. I really enjoyed my time making this, and expect to use what I've learned in the future for my personal projects.